Hello everyone, welcome to this video. My name is Amer Senahri, I'm a Google Earth Engine expert. Today I'm gonna show you how we can download soil moisture data with daily temporal resolution from the Google Earth Engine platform. In this tutorial, I'm gonna show you one of the most popular soil moisture products in the remote sensing collected by SMAP satellites. So let's go to the Earth Engine code editor environment, and for the first step, as same as we say in the same as we do in the previous YouTube tutorials in my YouTube channel. First of all, we need to identify the region of the interest. So as I'm an Iranian, and also most of the case studies I'm dealing located in Iran, and now in this tutorial I'm gonna select entire country as the region of the interest. And as you know, for the identification of the region of the interest, most of the time we prefer to use the shapefiles for the border of the country. And that's why we need to find a shapefile for bounding the satellite data based on. So accordingly, as I said in the previous YouTube tutorials, we can use FAO shapefile products for the country boundaries in the Google Earth Engine platform without having any shapefiles for the region of the interest. So for example, just in the first step, through the search places and dataset, type FAO administrative. As you can see, FAO global administrative country boundaries according to the 2015 update is available, and then import it into the code. And here we have it as a table, and if you click on, you will see the data description, table of schema, and also the feature view, and lots of things available here, and you can use them to get more information about these products. So back to the code. Now in the first step, we want to visualize the shapefile of country borders through the map.add layer. Map.add layer, inside the parentheses, just type table. After a few moments, you can see the countries according to the borders or political borders according to 2015 data. And now I want to select only the border of my own country, Iran. So just to do this, throw a marker available here, select your region of interest or inside the desired shapefile, and then make a new variable in the code. For example, my region of interest equals to, so from the imported table, through the dot filter bound, we can bounding our shapefile to the region of interest that is selected through a marker, and our marker identified as geometry in the code. So now from the all shapefiles, I need that shapefile that is correspond with my marker or with my geometry. So in the next step, now I will write map.add layer, but this time instead of the table we have ROI or region of the interest, and as you can see, the target shapefile selected and extracted from the main dataset or original dataset, that is table. So for the next step, I need to call soil moisture product in the Earth Engine platform. Just write a new variable, sm equals to, throw the search places and dataset, go to browse data catalog. In here, throw the browse by tags. You can browse all or explore all soil moisture products available in the time you are working with the Earth Engine products. Now in April 2024, I'm working with Earth Engine platform, and for now, only this soil moisture product is available. Here, with the soil moisture tag, you can see only 8 datasets available here. Click on and wait to see what kind of products available for now. Maybe in future, after 1 year, 2 years, and couple of years, you will face with a variety of, with various products in the Earth Engine platform for the soil moisture calculation. Anyway, but one of the most popular and one of the most famous soil moisture product with good spatial resolution is SMAP soil moisture product with 9 km spatial resolution that is downscaled to the 10 km or 9 km, because the original spatial resolution is less than this, and but here it is available with daily temporal resolution. And for example, 1 year ago it was with 3 days temporal resolution and coarser spatial resolution, but now this product improved, and maybe in future if you go to the Earth Engine platform you will see this product with some improvements in spatial or temporal spatial resolution that is possible through the machine learning algorithm. So the first product, if you go on the first product, it is radiometer daily data. It is available since 2015 to 2023. By the end of 2023, this product is available for now, and also it will be updated in future after 1 or 2 months. I don't know how exactly it changes, but and also the other products are available here. For example, we have another product with the same characteristic and daily temporal resolution. Now, yes, this product is available after for 2024, or since the after 2023 over, the new product published here, and also you can combine these kind of products together to make a continuous soil moisture product for your study. It's very easy to use in the Earth Engine platform, and also no need to do any further calculation. Just make another variable and call the second products and do your time series. And now in this tutorial I'm gonna show you how to deal with this product in the Earth Engine. It's very simple and easy to use, and I try to show you the simplest way to dealing with the satellite data in Earth Engine platform, because I know none of you or me are programmers, and also we just want to learn some script to get our data and use them in our modeling approach. So go to the daily 9 km product, because it's provided longer temporal extent, and through the IDs available here we can import it into the code. And here you will see that through the search places and dataset we have 2 datasets. One of them is version 005 and another one is 006. That 006 product is related to the day related to after 2023, meaning for 2024 and on. So, and here version number 5 imported into the code as an image collection, and then image collection assigned to the soil moisture. So that's you can see. So in the next step we need to select a specific band that's using for soil moisture retrieval. As you can see, various bands available here and also with their descriptions, but the main band including soil moisture information, it is soil moisture AM, that referring to the soil moisture data estimated from the early morning or from the morning. It is AM overpass. So now you need to select the band name, back to the code, and also through the dot select. Select is a function helping you to find or select or choose the target bands. So here inside the crochet, soil moisture AM selected here with 10 km spatial resolution, and then through the, you don't need to use filter bound or something like that, because it has coarse spatial resolution with daily temporal resolution. And then I need to use filter date to restrict this data for time span, or limit this data for the time span I need to study. For example, my time span is from 2020 to 2024. All the daily products available for this period, I'm gonna download them all, and then using the print you can see how many products available for this period of time. We have an image collection in the right side, it is under computation, and also because it has daily spatial resolution, maybe it's a little time consuming process to return the results, because most of the time daily products provided large number of satellite data and also make the processing a little heavy in the Earth engine. So as you can see, more than 1,300 images available for the soil moisture retrieval, and all of them available for a specific date with daily temporal resolution, and in each element one band soil moisture AM is selected. So in the next step I'm gonna show you how to estimate, how to produce different maps for the soil moisture in your region of the interest. All the techniques previously presented in the Earth Engine platform in my YouTube channel, and also just I want to show you how to use some of the existing method and also the previous method that I have showed you but this time for the soil moisture data. For example, previously we used this data for the temperature and NDVI, and now I want to show you how we can apply the same methodology for the soil moisture data and the rest of the products. Make a new variable here. For example, I want to make an average soil moisture map for my country. Soil moisture mean equals to get all soil moisture images and calculate the average value in order to avoid from if you want to avoid from extreme high or low values in the computations, use the median for the getting average. It's more useful. So, and get a median and then through the map.add layer, you will be able to see the final result. Soil moisture average for the last 4 years here, and then I want to clip it based on the region of the interest or ROI, and then leave the visualization parameters empty, or even you can use the data description to copy and paste the preferred palette or introduce palette for this data. So here, as you can see, I copy the palette and then paste it here, make a GUML like this and copy and paste the palette values, and then in the next line set the name for the layer setting. The layer setting is could be soil moisture average or something like that, and at the end set the false to avoid automatic loading final images. So save the code and run it again. After a few seconds you will have a new layer in the layer settings entitled soil moisture average or soil moisture mean, and now I'm uploading the final result. I'm trying to load the final result here, and you will see that. So it's again maybe a little time consuming process because more than 1,000 images involved into the processing to get an average in each pixel, and also it's natural to spend more time for the visualization or something like that, or even visualization process is very hard. For the heavy data, I highly suggest you to get an export directly through the export.image.layer in the Earth Engine platform. So as you can see, the result is showing, and also the same time I can show you how to get export from this product through the export.image.toDrive. You will see we need to add some arguments to get them export. The first is the image equals to the soil moisture mean or soil moisture average for the region of the interest, and the description referring to the output file name. The output file name is soil moisture average, soil moisture mean, and then set a scale as the spatial resolution is 9,000 meter, set 9,000 meter or 9 kilometer here, and region of the interest equals to ROI, and the CRS or spatial resolution is very important to get the original spatial resolution. Get soil moisture average for your region, and then through the get info go through the properties and information available for this band, and then .crs helping you to get the coordinate system value or information for the output. So, and the maximum pixel you allow to get export for each frame separately equals to 1E13, and also the target folder you need your data save in is, for example, you can write a name, automatically Google make a such folder in your Google Drive, and then you can download it from the target drive actually, or target folder. For example, I want to make a new folder with soil moisture name, and then the final result will be shown in such folder in my Google Drive. So now the image completely loaded, and through the inspector, if you click on each pixel, it shows the soil moisture value, in different pixels. Again, you can see it's a little taking time to show the value because it's a little heavy, and working with such kind of heavy data products in the Earth Engine is difficult, and most of the time I prefer to get it to download it from the Earth Engine and check it in my desktop softwares such as ArcGIS Pro and etc. And as you can see, the value is 0.09, and in the some regions, for example, you can see the brighter regions, actually the yellower regions showing the higher moisture, and the darker or bluish regions showing actually the lower soil moisture, yellowish higher soil moisture. And also it's as we expected. And also some of the water surfaces or urban surfaces, if it is detectable in 9,000 kilometer, it will masked or removed from the product. As you can see, Urmia Lake in the northwest of Iran removed from the product. And also, if you want to download it to use in the own software on the desktop, just click on the run, and in the right side panel, in the task, we have a soil moisture mean. Click on it, and then you can see this data is downloadable with 9,000 meter, and then click on run again. I'm waiting to get the download to download it. But now the process of saving started into the Google Drive, and after the tab color turned to the blue, it meaning that the process of saving is completed and so was successfully completed. And also then we can pick it up from the Google Drive and open it up into the ArcGIS Desktop, ArcGIS Pro, and the other softwares or geospatial softwares you are working, because the output format will be GeoTIFF, and it is usable in all the softwares, in all the geospatial softwares, because it is a typical format. So back to the programming step until the process of saving is over. So now in the next step, I'm gonna show you how to get the time series of soil moisture for 1 or 2 points in your region of the interest. It's very simple and easy to use process. Just you need to select a region, or and also it can be a point, or it can be a rectangle. For example, I want to select a point to assess the soil moisture for the selected point here. So now, using the print and user interface chart, you will be able to make a chart to see the time series values for 1 pixel. Image.series, there are some arguments here. One of them is image collection. Instead of image collection, we need to have soil moisture mean is one single image, and we are unable to use one single image for the chart.time series, because when you are working in the chart.time series, meaning that you need to have an image collection starting from a specific point, date point, to and ending to a specific date point. So accordingly, here we need to set the soil moisture that's including more than 1,000 soil moisture products, and instead of the region, we need to set a region that we need to get its soil moisture value over the time span. That here is geometry number 2. And then the reducer is very important. When you select a region or rectangle or polygon, you need to set, you can get the average, minimum, maximum, or something like that. But most of the time when you are dealing with the point with the marker to get the value over the time, would be better to use a reducer that first that get the first and nearest value to the selected point. Earth engine that reducer that first helping you to select the nearest pixel to the selected point to plot the soil moisture time series. And instead of a scale, import the spatial resolution value that is 9,000 meter or 9 kilometer. And also here, instead of X properties, we need to have system time start, and run it again. In the right panel, you can see there is a chart that is generating, and after a few moments we can see the daily soil moisture for the selected point from 2020 to 2024. You can see that the chart image.series can be usable for all the image collections in the Earth Engine platform. All the image collections, including system time start, in their property, you can plot their time series very easily. So the chart is generating. Again, the process of calculation is a little is taking time, and also you can reduce the temporal resolution to the monthly, 10 days, or whatever you want. And here you will see the variation of the soil moisture in the different dates. And as you can see, in the January, December, February, March, in the months with higher precipitation, we have higher soil moisture value, and in the months with the lower soil moisture, with the lower precipitation and lower soil moisture expected here. But this is with daily temporal resolution, and maybe the daily data include having some noises, but you can convert them to the 3 days or weekly or monthly product easily through the temporal collection that is available in the Earth Engine, that you can write its function in the Google Earth Engine platform. For example, in the previous studies, in the previous tutorials in my YouTube channel, I showed you how we can use the temporal collection function that is developed by the Google Earth Engine developers, and helping us to convert the daily data to a various temporal extent from daily to weekly, monthly, and seasonally and yearly. It's very easy to use, and here I'm going to show you how we can use that for the soil moisture product. The process of writing the function is same as I showed you in the previous tutorial, and also there is no difference, but the only difference is the input data here. In the previous studies or in the previous examples, I used, for example, temperature or NDVI or precipitation, but here the input data is soil moisture. And as I mentioned in the previous tutorials, if writing temporal collection function is a little too much for you, you can copy and paste it from my own code, that its link is available below the video in the description box. And feel free you use it, because I'm not developer of these codes. These are available on the net. If you search and go through the net, you can see that the Google developers shared this code with all the users, and just I'm here to show you how you can use this code for different products to get your desired data. It's very simple and easy to use, and if you had any problem, first of all, I suggest you to compare your code with mine, and also if a still problem exists, you can reach me out and put your comments, put the comments in my YouTube channel. I will check and answer them and try to help you and solve the problems. So, and now I'm going to show you how to write the temporal collection function. Just make a new function, and when we want to make a function, the line starting with a function, and the function name here is temporal collection. Temporal collection including various or couple of arguments. The first one is collection, and the next is a starting date, and the next one is count, and the next one is the count, meaning the number of output images we expected, and collection, sorry for some fast typing without description. The collection here refers to the input image collection for this function, and start referring to the start time, and count referring to the output images we expected with different interval or temporal extent. And then at the end we have a unit that's referring to the unit of time. For example, if you want to get the daily output, the unit should be daily. If you need to monthly data, the unit should be months. If you want to get output with weekly, the unit should be week. So now in the body, we can write the code structure and also coding steps. In the first step, make a new variable as sequence equals to earthengine.list.sequence. Now we want to make a list for the outputs according to the number of images expected. So the number of images expected, or the list starting from the 0 to the number earthengine.number already set for the count, and as the counter starting from the 0, we need to get subtracted from 1. In the next step, make a new variable as origin date or starting date origin date equals to earthengine.date. It is true that we have a start argument but it is imported with a string format, and through the earthengine.date can be converted from the string to the date format. Start date to actually the start imported with the date format here. And finally, we need to return the created list with the image collection format. earthengine return earthengine.image.collection equals to, inside the parentheses we have a sequence, we have a list of sequence, and then through the map I need to make a function in which each input image is considered as an ing, and inside the parentheses for each row in this list we need to set a start date and end date. Make a new variable start date equals to from origin date dot advance go forward with the delta and unit. The delta time equals to earthengine.number. We have interval actually. Number, we have interval value that multiply to each row, that each row should be considered as an I. Each row in the list is an I, and also we consider or interval, a time interval for each row based on the unit already defined here. No need to set the time zone, and then make another variable. Sorry, there is something wrong here. So the next variable is end date equals to get origin date again dot advance go forward, but with a little difference. earthengine.number interval, instead of the delta, as you can see, there are a couple of arguments here. One of them is the time delta. earthengine.number again we have interval dot multiply 1 unit after I. earthengine.number I dot add 1, because we need to select 1 unit after. The unit is same, just remove the time zone from here. So the function returning the input collection. Here, as you can see, we had an input collection, return collection, and also then we need to limit it to the start date and end date. Through that filter date, limit your input collection to the start date or end date, the period of time defined through the start date and end date according to the interval expected. And then for this period of time, for example, we want to get an average or median or maximum or minimum. That depends to your application, but typically we get the average, and then you should set system time start and system time end as a key properties for the time series analysis. So that's set system time start equals to time start date dot millisecond format, because Earth Engine working with the dates with millisecond format. Again, dot set system time end according to the end date and with millisecond format. So now the function is ready, and we can apply this function on existing elements or existing image collection in the console part, so or in the code actually. So make a new variable. For example, I need to get weekly soil moisture value. So here there is a weekly equals to, now type the temporal collection function here. Let me to make a bigger space for coding. So here we have a function temporal collection, and also with various with couple of arguments. The first collection, a start, count, and interval. And now we need to replace each argument with a real value. Instead of collection, we have the soil moisture product. A starting date is 2020. As I mentioned, as you can see, this is with string format, and Earth Engine dates start helping us to convert this string value to a date. And then instead of count, what we should import is important here. For example, let me to show you in the calculator. As you can see, each year we have 52 months for each year. So sorry, you can't see my calculator here because it is already opened in another display, and also I can't show you, but just I can type it here for you. As you in the text format, as you can see, each year equals to 52 weeks, and now we are working on 4 years, 2020, 21, 22, and 23, completely 4 years. And now we need to multiply 4 to 52 equals to, let me try to do it in the calculator. Sorry, you can't see the calculator. 4 multiplied to 52, we will have 28 weeks for 5 years. So now set the 208 for the count or number of output images expected, and interval referring to the temporal difference or the delta. Actually, as we need, as 4 years consisting of 208 1 weeks, and also or 208 weekly data with 1 week interval for each week, not 2 weeks or 3 weeks. So the interval should be equals to 1. So, and the unit should be week here. So now print the weekly result. In the right panel, you can see the final result. One image collection under computing. There is no error yet, meaning that hopefully we had no syntax error, but now we should check if there is any semantic error or not. As you can see, for each date we have one band that's showing our computation was true, and also there were no problem. But for some days, because of the gap or some unavailability of data, the code couldn't make the weekly image for some specific dates. And sometimes such kind of errors in the multi-temporal collection happens just because of temporal gaps in the data. So it doesn't matter, just you can use the chart.image.series to visualize the results. And here, as you can see, the weekly data is available. We can get the weekly value. Instead of the soil input soil moisture, we want to get weekly for the selected point, and also the same system time start, because already system time start defined for the weekly data. And also you can see it with millisecond format in the code which has been written above. And here you can see it's it has less noises and also has a better shapes, because when you convert it from the daily to the actually from daily to weekly format, the temporal lots of noises in the pixels will be removed or combined with the other true pixels through a time. So for monthly format, just copy the previous code and paste it here. Now, so for monthly format, you need to change something in the argument. The same collection, the same start date, but the only interval and also the number of output changed, and also the unit. Instead of week, we will have months, and also each year equals to 12 months. And now 4 years multiplied to 12 months equal to, for example, in the calculator, I do it in the calculator to avoid any mistake. 4 years multiplied to 12 equals to 48 months. 48 count with 1 month interval. So now through the print, you can see the monthly format easily. So yes, and now instead of weekly here, we have monthly, and replace weekly with monthly with the same arguments. In the right side, now you can see the monthly temporal variation of soil moisture according to the soil moisture data retrieved from SMAP satellite with 10 kilometer. Yes, this is the monthly format. In wet months, higher soil moisture, and dry months, lower soil moisture. So for the annually, and now you can change it to the annually. For example, copy and paste it again. Instead of monthly, just type the annual one, soil moisture from 2020, 4 soil moisture images with 1 year interval. So with 1 year, and now we have the annual images to compare different years to see which years having higher moisture and which year including lower moisture for the selected region. So yes, there is, as you can see, this is the annual soil moisture values. For example, the lowest soil moisture value is related to 2023. So that's the how soil moisture product works in the Earth Engine platform, and you see that how we can call and how we can convert these products and how we can download them through the Earth Engine. And also the product, the average product is also ready through the opening drive. You can go to the Google Drive. Inside the folder, soil moisture average is available, and download it and open it up in your own software. And also these are the time series data. Also you can download them through the plot functions available here. Through the download CSV, you can see the variation of the soil moisture for each month separately. I hope you like this tutorial as much as I do, and also if you had any problem, feel free to ask me your questions and share your code below this video in the comments part, and I will check and answer your questions as soon as possible. Thank you for your attention.